Hello children, consider this quadratic equation 2x squared plus x minus 4 is equal to 0. Let us find the roots of this equation. Let us find the factors and hence find the roots of this equation using completing the square method. That is, this of course is obviously not a perfect square, but we would make it into a perfect square and hence solve this equation. So, in order to do that, we should know how a perfect square polynomial, p plus q the whole square, would look like. It would look like p squared plus 2pq plus q squared. Now, completing the square here means that we have a p term, isn't it? This can be said as a p squared term because it is also x squared. This looks like p squared, but just that we have an extra 2 here. We have an extra 2 here. We can eliminate this 2 easily by just dividing the equation by 2. Every term of the left hand side can be divided by 2 and the right hand side also can be divided by 2. This would leave the equation unodd term. So let's look at the new equation now. You have 2x squared by 2 becomes x squared plus x by 2 minus 4 by 2 becomes 2. This is equal to 0 because 0 by 2 is 0. Now you can easily compare this p squared to x squared. So x squared stands instead of p squared. And since this has an x term, which is actually p, you can say that this stands for 2pq and we can find out what is q using this particular term. You can say what is q. Just equate 2pq to x by 2 and you know that p is equal to x. So, we will not mention the p and x here. So, 2q is equal to 1 by 2. 1 by 2. We only need q. Why do we need q? So that we add here q squared and complete this square. So, q is equal to 1 by 4. Now, let us proceed with the equation. Just add a q squared here. That is, we already have an x squared which stands for p squared. We just have to add this q squared. So, x squared plus x by 2 which stands for 2pq plus this q squared. Let me add it in red to just show the difference to you. 1 by 4 the whole square. But we cannot just add something and let the equation be. This alters the value of the equation. So, subtract the same quantity to the equation. So, in effect this becomes 0. It becomes null. So, you haven't changed the equation. But at the same time, you are going to use this first 3 terms of the equation to make it into a complete square. And mainly, please do not forget this minus 2 here. Let us repeat it here. I'll repeat it in blue because it is that old equation. Minus 2 is equal to 0. Now, as I said before, these 3 terms can be written in this form. How? As x plus 1 by 4 the whole square. Now, we have completed the square, but just that we have some constants left. So, shift the constants to the right hand side of the equation. It becomes 1 by 4 the whole square plus 2, or what is 1 by 4 the whole square? It is 1 by 16 plus 2. So, now we need the denominator to be 16. It is 1 here. So, just multiply both numerator and denominator by 16. You get 32 by 16, isn't it? This becomes, let me write it for you. This becomes 1 by 16 plus 32 by 16. It can be added now as the denominators are the same. And now your equation would look like x plus 1 by 4 the whole squared is equal to 33 by 16. Now, the aim of all this was to find x, isn't it? The aim of all this was to isolate the x so as to find the roots of the equation. So, how do we isolate x? Just take square roots on both sides so that the square part is taken care of. So, what is the root of x plus 1 by 4 the whole square? It is just x plus 1 by 4. And what is the square root of this side? It can either be positive or negative. Root 33 root 33 by root 16 is 4, isn't it? It's plus or minus 4. So it's 4. Okay. And now for the isolation of x, which is our final solution. So x would be equal to minus 1 by 4 plus or minus root 33 by 4, or it can also be written as the two roots separately. The first root is minus 1 by 4, or let me put it in straight 1, yeah, here, minus 1 plus, let me write it clearly. It is, sorry for, yeah, minus 1 plus root 33 by 4, or the other root could be minus 1 minus root 33 by 4. I hope you understood how to go about completing the square thoroughly. Thank you.